I am now going to work through this Math 201 test number 1 review. This is the review right here. There's not really room to work the problems out on this review, so I will rewrite each problem. And of course, the last page is the key. So I'm going to actually tear this off, and as I'm working through these, I will check the key and make sure I don't make any mistakes, and even make sure that the key is correct. This is something I've just now created in the last few weeks, so there could be some mistakes in here. So let's just jump in. I will work these problems out, and as I'm working them, explain what I'm doing. And hopefully that may help you as you're trying to learn this stuff yourself. The first few problems I'll deal with what I call function notation, just understanding how to write functions and the different kinds of things they do with functions. This first problem, we're given this function f of x equals x squared minus 4, and then we're asked to compute various functions where, so what this notation means is f of 0 means every place you have an x in your function, replace it with 0. So it's almost like, so basically x squared minus 4, I'm going to replace x with 0. So 0 squared minus 4 equals negative 4. So we say f of 0 equals negative 4. Just a little background. Before we started using function notation, you probably learned to do things with x and y. F of x and y are always interchangeable. They're really the same thing. But now as we get into calculus, it's helpful to think about things as functions and function notation. So instead of using x and y, it's more common to use f of x. But the problem we solved here, f of 0 equals negative 4, that's really the same thing as saying if x equals 0, if I plug a 0 for x, then y equals negative 4. So it's the same idea, but now we're using function notation. It's actually a sort of a more clever and easier way to determine these kinds of things. So then the next one in problem 1, there's like 6 or 7 of these maybe. Let's say f of 1. So once again, every place I have an x in my function, I'm going to replace it with 1. So f of 1 equals 1 squared minus 4. 1 minus 4 is negative 3. The next one, f of 2. Every place I have an x, replace it with 2. So 2 squared minus 4. Looks like 4 minus 4, so f of 2 is 0. All right, hopefully you're seeing these are not really very difficult once you understand what to do. F of negative 2, be careful now. X squared, I'm replacing x with negative 2, but the negative 2 gets squared. So I need to put this inside parentheses. Do you realize in the strict mathematical sense, these are not the same? The parentheses here means everything inside the parentheses is squared. So this would be minus 2 times minus 2. This would be 4. This notation right here says take the 2 and you square it, and then you make it negative. I see this a lot where students, they really mean this, but they write this. And oftentimes, first of all, these are not the same. But even if they do the math correctly, sometimes they forget, and they will call it this. So obviously these are not the same, which means these are not the same. So in the world of math, you have to be careful with notation. If you don't have parentheses, when you have an exponent, that exponent only is applied to whatever it's next to. If I want minus 2, that whole thing to be squared, I have to put it in parentheses, so then the whole thing is squared. So going back, so f of negative 2 and negative 2 squared minus 4, which is 4 minus 4, which is also 0. And now they do something a little different. F of a. So what this says, instead of all these examples so far have been numbers, now it's f of a, which basically says, okay, so take your function, every place you have an x, replace it with a. So my function is x squared, so it becomes a squared minus 4. A couple more. F of 1 over a says every place you have an x, replace it with now 1 over a. So 1 over a squared minus 4. So I square the 1, I square the a. So f of 1 over a is 1 over a squared minus 4. And the last one, f of the square root of a. So I go to my function, every place I have an x, I replace it with the square root of a. So square root of a squared minus 4. So when you square a square root, you're basically left with what's inside the square root. So we just have a minus 4. As I was doing these, I was checking the key, and it looks like these are all the answers on the key. Now number 2, it's really the same problem as we just did, except a different function. And actually on the key, I have a typo because the key says x, but it should read f of x equals x over x plus 4. And then they say, what is f of 4? Same idea. Here's my function, f of x. F of 4 says every place I have an x, replace it with 4. So 4 over 4 plus 4. 4 over 8, I will reduce that to 1/2. F of negative 4, every place I have an x in my function, replace it with negative 4. So negative 4 over negative 4 plus 4, negative 4 over 0. Okay, now at this point, in math, we can never have a 0 in the denominator. We can never try and divide by 0. Whenever that happens, we just stop and we say it's undefined. No solution, or undefined. So the rest of these, f of 0, so 0 over 0 plus 4, so 0 over 4. Now, because the 0 is in the numerator, that's okay. 0 divided by 4 is just 0, so that would be the answer. And then the last couple, so these are a little different. F of x minus 4, but the principle is still the same. Here's my function f of x. F of x minus 4 says, okay, every place I have an x in my function, you replace it with x minus 4. So every place you have an x in the function, you substitute x minus 4. So I have an x in the top, which becomes x minus 4. I have an x in the bottom, which becomes x minus 4, and then plus 4. So x minus 4 over x. Then the last one, f of x plus 4. Same thing, every place you have an x in the function, replace it with x plus 4. So I got an x plus 4 in the numerator. I got an x plus 4 in the denominator, and then plus 4. So this is x plus 4 over x plus 8. All right, pretty simple function notation. Now problem number 3 is also function notation, but now we're given what we call a piecewise function. A piecewise function is where the function actually changes and the function that you're going to use is determined by the value of x. So let me just copy this down. Here's what it says. So basically the function is not always going to be the same. The function is going to change according to what your value of x is. Now this one actually has 3 parts to it. So it says f of x up here, that's not a very good square root. F of x equals square root of x plus 2 if x is less than 0. So if we decide x is equal to negative 10 or negative 5 or negative 1, in other words, if x is less than 0, or you could say if x is a negative number, this is the function we're going to use. Now we say the function is equal to infinity, which is interesting, if x equals 0. So if we're ever given a problem where we're asked to find the function when x is 0, or we would call that f of 0, then we would use this middle function. It basically says, hey, the function is infinity. All right, it's a little different, but it's okay. And then the third function, f of x equals x squared, if x is greater than 0. So it's almost like for this piecewise function, the function is broken down. Really, you can think of it almost if x is positive or negative. If x is negative, if x is a negative number, you use this first function. If x is a positive number, we use the last function. And if f happens to equal 0, we use this middle function. So now, for this piecewise function, we want to calculate f of negative 4. So with a piecewise function, the first step is to look at your value of x. So I want to set x equal to negative 4, and I have to go figure out which function I'm going to use. Which function is the correct one when x is negative 4? Well, it's this first one, because this first function says, hey, if x is less than 0, this is the function we're going to use. So therefore, f of negative 4, so now every place I have an x, I replace it with negative 4. So f of negative 4 is the square root of negative 4 plus 2, which is the square root of negative 2. Now, hopefully you remember in math, what happens when you try and take the square root of a negative number? It's undefined. In other words, we cannot take the square root of a negative number. Let's take a minute and talk about this. Maybe most of you understand this, but in case someone doesn't, why is this the case? Well, the square root says, what two numbers can I multiply together that's going to equal this? In other words, let's look at a more common one. Square root of 4 says, go find a number that I can multiply by itself and it equals 4. So square root of 4 is 2. Because 2 times 2 equals 4. Now what would happen if I try to take the square root of negative 4? So what I'm looking for is a number I can multiply it by itself to equal negative 4. So maybe some of you think, well, how about negative 2? Okay, negative 2 times negative 2. Once again, I have to multiply it by itself twice. But what's negative 2 times negative 2? It's 4. It's not negative 4. The only way I can get negative 4 is if I multiply negative 2 times 2. Then I get negative 4. But the idea of a square root is you're looking for a number you can multiply by itself. In other words, it's impossible to find a number that I can multiply it by itself to equal negative 4. So this is why whenever you have a negative under the square root, we say it's undefined. Really, we can say it's not a real number. Sometimes in the world of math, we will start talking about imaginary numbers and complex numbers, but we're not going to deal with that now. Basically, we're just going to say it's undefined, it's not a real number. All right, going on. What's the rest of these? F of negative 1. So once again, we got a piecewise function. First step is to say, what is my value of x? X is negative 1. Therefore, which of these functions applies? So once again, this first function is what I'm going to use if x is less than 0, or in a sense, if x is a negative number. So once again, I use this first function. So every place I have an x, replace it with minus 1. So negative 1 plus 2, square root of 1, square root of 1 is 1. So f of negative 1 equals 1. And some of you might think, well, isn't the square root of 1 plus or minus 1? Yeah, it could be, but for now we're just going to use the positive root. Okay, two more. What is f of 5? So in this case, x is 5. So we go back to our piecewise function and figure out which function we need to use when x is 5. So x is a positive number. It looks like the third function, because this says if x is greater than 0. So we could think of this as the function to use when x is a positive number. So therefore, every place I have an x, I put a 5 in. So f of 5 should be 25. And the final one we're asked to determine is f of 0. Same procedure. So x is going to be 0. Which function do I use when x is 0? As it turns out, this middle function is the one you use. It's interesting, this function is only used when x is 0. These other functions can be used for all different kinds of values for x, but when x is 0, it's this one, and it basically says the function's infinity. So I just put f of 0 equals infinity. All right. So now one more problem with function notation. So here's the different application, which actually is a pretty important little expression that is going to become important in calculus. Matter of fact, it's called the difference quotient. And here's what it is. It's f of x plus h minus f of x over h. Now what we're going to do, part A, they say here's your function, here's a function, f of x equals x squared plus x plus 5. And the point of this problem is to take this function f of x and to calculate this expression. So the key is we've really got two parts we have to worry about. We have f of x plus h. So I'm going to take my function, and every place I have an x, I replace it with x plus h. And then we subtract f of x, which is actually just my function. And then we have to sort of simplify and see what happens. So let's look at this first part and do it sort of separately. So I need to figure out what f of x plus h equals. So once again, here's my function. I'm going to every time I have an x, I'm going to replace it with x plus h. So my function says x squared, so that becomes x plus h squared. So x squared plus x, but instead of x, I put in x plus h. So x squared plus x plus 5. Now I need to go and simplify this, and that means I'm going to get rid of these parentheses. Now this one is squared. So hopefully everybody realizes what that means is x plus h times x plus h. You square the whole parenthesis. So most of you learned how to FOIL. So I'm going to try and do this in one step. I believe it should be x squared plus 2xh plus h squared. So now, this f of x plus h, here's the squared part. X squared plus 2xh plus h squared plus x plus h plus 5. Now I need to see if I can combine any like terms, and as it turns out, actually none of these are like terms. This is x squared, this is xh, h squared, x, h, and 5. So this, once again, this whole thing here is my f of x plus h. I've got to plug that in up here, and then I've got to subtract f of x, my original function. So let me try and make way to show that. Let me sort of fold this over. So once again, here's my original expression, this difference quotient. Here's the function I'm given. This is my f of x plus h. So I'm going to write down all of this. Well, let me just make it clear. Okay, some of you, because this can get sort of messy. So f of x plus h is this big thing right here. That is f of x plus h. Then I'm going to subtract f of x, just my original function. And I'm going to put this in parentheses because I got to make sure when I subtract it, I'm going to subtract every term inside here. X squared plus x plus 5. So here's the f of x plus h minus f of x, and then it's all over h. Now I'm not going to skip any steps just to make it very clear what we're doing, because what I need to do here is, when I get rid of this parenthesis, because I'm subtracting it, subtract that minus sign gets applied to every term inside. So let me just rewrite this part. Nothing changes in this first part of this. Now, this parenthesis, it's minus x squared minus x minus 5. Now, whenever you have one of these difference quotient problems, you know you've done it correctly at this point. A lot of this stuff in the top should cancel out. So for instance, I'm going to combine like terms. Here's an x squared. Are there any other x squared terms in here? Turns out right here. In fact, it's minus x squared. So what's x squared minus x squared? They cancel out at 0. So normally what you do is you just sort of mark those out because they cancel out. Next, I have 2x plus h. I don't have any more of those. So I go ahead and write 2x plus h. I sort of check it just to keep track of things. Here's an h squared. Any other? Nope. Now here's x. Here's another x. So it's negative x. So x minus x, those cancel out. Now here's h. And what's left? Okay, here's 5. And I got a minus 5 here, so 5 minus 5, those cancel out. So when I combine like terms, I'm left with this, and it's all over h. Now here's a case where you have to look and see if you can reduce. And the principle is, I have 3 terms in the numerator, and I've got an h in the bottom. If I have an h in all these 3 terms, then I can cancel this h and divide out an h in all these terms. So since I have an h here, an h squared, and an h, I can go ahead and cancel this. And the 2xh just becomes 2x. H squared over h becomes h, and h over h is 1. So then this difference quotient, when I'm all done, should equal 2x plus h plus 1. All right, that was a lot of algebra, sort of messy, but unfortunately that's what happens when you do these difference quotients. Now that was part A. Part B, they give us another function. Now the function looks simpler. We'll see what it's like once we actually find the difference quotient. So once again, let's write down the difference quotient. So for this function, we're asked to determine the difference quotient. So once again, now let's see if we can do it at the same time. So f of x plus h. Here's my function. I'm going to replace x with x plus h. So this first part is going to become 1 over x plus h. So there's f of x plus h. Minus f of x is just my function, right? So this is f of x plus h minus f of x, and the whole thing is over h. Now this is a lot less terms than up here, although this is not necessarily simple. It has its own problems because now I've got some fractions here over another number. So this is like a complex fraction. So yeah, this doesn't look as messy as up here, but I've got to do some work here and I've got to do some algebra. So actually I need to combine these two fractions. And hopefully you remember, to subtract fractions, you have to have a common denominator. So if I look here, this denominator is x plus h, this denominator is x, so it's almost like my LCD is going to be x times x plus h. So let me just take this piece of it and let's go off and try and subtract out those two fractions. So let's just do that separately. Since my LCD is going to be x times x plus h, I need to convert both these fractions to where they have the common denominator, this LCD. So this first one, currently I have x plus h. I need to make this denominator x times x plus h. So I need to multiply the bottom times x, but if I multiply the bottom times x, I have to also multiply the top times x, because x over x equals 1. So I'm not really changing the value of this fraction. So when I do this, 1 over x plus h becomes x over x times x plus h. So now I've taken this fraction and I've rewritten it to have the common denominator. Now 1 over x, once again, I need this fraction. I need the denominator to be x times x plus h. What do I need to do to this original denominator? I need to multiply it by x plus h. Of course, if I multiply the bottom by this parenthesis, I also have to multiply the top by that parenthesis. So 1 over x now becomes x plus h over x times x plus h. So now I've converted both fractions to where they have the common denominator. So now I can actually subtract. And you remember, when you subtract fractions with the common denominator, you write the common denominator in the bottom, and then you subtract. So x, so this is minus x plus h. So it's going to be minus x and also minus h. All right, you got to keep track of your positive and negatives. That's where a lot of students will make mistakes. So x minus x, these cancel out. I'm actually left with negative x over x times x plus h. So what have I gotten? So this whole numerator here is now this. So let's go ahead and plug this back in up here and let's see what we've got. So once again, this problem is getting messy fairly quickly. So once again, let me get a new sheet of paper so we can finish this. So once again, a quick review. The function was 1 over x. We were asked to find the difference quotient. Initially, doesn't look too ugly, but we had to go in and combine these two fractions, which is this. So now I'm going to plug this in for here. You can see that. So this new fraction becomes negative h over x times x plus h all over h. So this goes in here. Now we still have a complex fraction. However, I can simplify this. And the way you simplify this complex fraction is, in case you haven't done it for a while, this h I can think of as h over 1. So whenever you have a complex fraction, which means a fraction over a fraction, the shortcut way to do this is you write the top fraction and you multiply by the reciprocal of the bottom fraction. So the reciprocal of h over 1 is 1 over h. And then, as it turns out, this h in the top is a factor, this h is a factor. Those cancel out. So I'm left with negative 1 over x times x plus h, and I think in the key, they went ahead and multiplied out this parenthesis, so either one of these answers is correct. All right. So it's true. These problems where you're asking to figure out this difference quotient can usually be pretty messy. It's sort of unavoidable. All right, so that's the first 4 problems. Let me go and stop now, and I'll start problem number 5 with a new video.